All right, picking up where we left off yesterday, we're going to now talk about the division properties. All right, so the first division property that we're going to talk about will be the quotient of powers property. All right, now remember, quotient just means division. So what is that going to mean for us in words? The quotient of two non-zero numbers I should say powers with the same base equals the base raised to the difference of the exponents. All right, so the quotient of two non-zero numbers, two non-zero powers, with the same base, that's important, same base, equals the base raised to the difference of the quotients. So if you remember, when we were doing the product of powers property, when we multiplied bases that are the same, we would add the exponents. And now, when we are dividing by bases that are the same, we're going to subtract. Remember, difference means subtract. So let's take a look at what that looks like in numbers and then in variables. All right, so for numbers, if we have two non-zero powers with bases that are the same, such as 6 to the 7th divided by 6 to the 4th. Notice our bases are both 6, and our powers are non-zero numbers, the 7 and the 4. Okay. So it says the quotient of two non-zero powers with bases that are the same equals the base raised to the difference of the quotients. And remember, difference means subtract. So you're going to go 7 minus 4. So that should equal 6 to the 3rd. Now let's see what it would look like with some variables. All right, so if we have some non-zero power, bases that are the same. So let's say we had a to the m divided by a to the n. So we have two non-zero powers with bases that are the same. Remember, our bases are both a. They're going to be equal to that base, a, raised to the difference, m minus n, the difference of the exponents. All right, let's take a look at an example that you can work out. So let's say we had 3 to the 5th divided by 3 to the 2nd. Well, our bases are both 3, so it's going to be equal to the base raised to the difference of the exponents. So that should be equal to 3 to the 3rd. All right, now one for you. And I'll have you do it with variables. Let's say you have x to the 6th divided by x to the 4th. You give that one a try. All right, next we have the positive power of a quotient property. Positive power of quotient. It's going to look a little bit different when it's negative. All right. So what do we have here? The quotient raised to a positive power equals the quotient of each base raised to that power. All right. So a quotient raised to a positive power equals the quotient of each base raised to that power. Okay? Just remember, quotient means division, so quotient to us right now is going to really stand for a fraction. A quotient raised to a positive power equals the quotient of each base raised to that power. So let's see what this is going to look like. All right, first in numbers. Okay? So let's say we had a quotient such as 3/5 or 3 divided by 5, and it was raised to the 4th power. Well, if we open that up, remembering what we know about powers, means to use this base, 3/5, as a factor 4 times, you're really going to have 3/5 times 3/5 times 3/5 times 3/5, which really could be rewritten. If we're going to multiply this out, we're just going to multiply straight across.